In this video, we are going to learn about antiderivatives. Okay, and as the name suggests, uh, this has something to do with derivatives. Okay, so let me show you what that means. Let's say, for example, that we have a function f of x equal to x squared. What is the derivative of that function? Well, very simple. The derivative of that will be f prime of x equals 2x. Okay, so 2x 2x is the derivative 2x is the derivative of x squared. So 2x is the derivative of x squared. But what do you call x squared? X squared is called the antiderivative of 2x. Okay, so antiderivative of 2x. So that's how it works. So when you have a function, you find its derivative, you call it the derivative. But what do you call the original function? You call it the antiderivative. So it's kind of like the reverse process of differentiation, and the reverse process is called anti-differentiation. That's why the result is called an antiderivative. Okay, so for example, if you were given a function 2x and you're asked to find the antiderivative, all you need to do is think of a function whose derivative is 2x, and one of those functions is x squared, as we have seen. Okay, so if you take 2x, you find a function whose derivative is 2x, you'll get x squared. But the question is x squared the only function that satisfies that criteria? The answer is no. Okay, in fact, if you have a function, say g of x equals x squared plus 1, this will also qualify as an antiderivative of 2x, because if you find the derivative of x squared plus 1, you'll still get 2x as an answer. You can have, say, x squared plus pi. Pi is a constant, so if you find the derivative of x squared plus pi, you'll get 2x. So in reality, there are infinitely many antiderivatives for a function. Okay, and so to sort of summarize everything, we say that the antiderivative, or the general antiderivative of 2x, will be a function of the form h of x, or we actually use big letters. Let's say f of x equals x squared. Now, instead of writing plus a number, a constant, we'll just put plus c. And this c will represent all of the constants that you can think of. So that's the general antiderivative. Now let's have few examples here. Okay, so let's say that our function is f of x equals 12x squared plus 2x. Find the antiderivative. What we have to do is we have to think of a function so that when we differentiate that function, the answer is 12x squared plus 2x. And the way that we will do that is we're going to look at the terms one by one. So first we're going to look at 12x squared. So what function? So let me put the big F of x here. The big F of x will be the antiderivative of the small f of x. Okay, so what function gives us 12x squared when we find its derivative? The answer to that would be 4x cubed, right? because if you differentiate 4x cubed, what you get is exactly 12x squared, and that's that term right there. So the first term for our antiderivative would be 4x cubed. Now what about plus 2x? What function gives us 2x when we differentiate? Well, that would be x squared, right? That would be x squared. Now this in itself is an antiderivative, because if you find the derivative of this function, it will give you this. But again, that's not the only antiderivative. There are infinitely many antiderivatives. So to sort of collect all of those infinitely many antiderivatives, we're just going to put plus c here, plus c. So the c will represent all the constants. Okay, let's have another one. Say f of x equals cosine of x. Now this is very straightforward. What function gives us cosine x when we differentiate? Well, that function will be sine of x, right? Because if we differentiate sine of x, it will give us cosine of x. But then again, sine x is not the only antiderivative. Sine x plus 1, sine x plus 2, those are also antiderivatives. So to collect everything, we're going to put plus c. The c there will represent all of those constants. So that's our general antiderivative. Okay, now in mathematics, we use notations to simplify the questions and how we write the expression. Okay, so instead of writing the sentence or the words, instead of writing find the antiderivative, we use notations to replace the words. Okay, and the notation for antiderivative or finding the antiderivative will be this symbol right here. It's like an elongated s. Okay, so that, and partnered with the x. Now the x is a variable, so it depends on what variable you're using. If you're using y as your variable, or you're using t or s as your variable, this will vary. Okay, so that could be ds, dt, dy, dw, or du. So it depends. Okay, and then your function will go here in between. So for example, if let's say you're trying to find the antiderivative of 3, okay, so instead of writing find the antiderivative of the function f of x equals 3, you can just write this entire thing, which is very convenient, right? So you just have to write this elongated s, and then you write the function in between that and the x, whatever variable you're using. So technically, this entire expression is asking for the antiderivative of 3. Okay, and so let's answer. So what function gives us 3 when we differentiate? Well, that function is 3x, and of course don't forget plus c. So the antiderivative of 3 is equal to 3x plus c. Now let's have another one. Find the antiderivative of 1 over x to the power of 6 dx. Okay, so same thing, same question. What function gives us x to the power 1 over x to the power of 6 when we find its derivative? Well, in this case, this is not too obvious. So we're going to be needing some theorems here. And the theorem that we can use is this theorem. It says that the antiderivative of x to the power of n is equal to x to the power of n plus 1 divided by n plus 1 plus c. Okay, so this is called the power rule. Okay, now you might ask, okay, this is x to the power of n, but this is 1 over x to the power of 6. So clearly that doesn't look like this. But we can do something about it. We can write it as the antiderivative of x to the power of negative 6, right? Because when it's on the denominator, we can put it on the numerator, but we'll put a negative in the exponent. So that will be the antiderivative of x to the power of negative 6 dx. And so all we need to do is just follow the rule. So it will be x to the power of negative 6 plus 1 divided by negative 6 plus 1 plus c. Okay, and so that will be x to the power of negative 5 divided by negative 5 plus c, which we can write as negative 1 over 5 x to the power of 5 plus c. And this will be your general antiderivative.